Hello everyone, welcome to Clashing Coder. So in this video we will see the question 567, that is permutation in string. So this question is one of the question on the Leetcode, and it can be asked in an interview also for Amazon, Facebook, etc. So this is based on a string and something related to anagram. So let's see the problem statement of this question, then I will explain you how you can approach this question and answer this question to the interview or solve this question in on the Leetcode. So let's see the problem statement. Given two strings s1 and s2, write a function to return true if s2 contains the permutation of s1. So in the other words, one of the first strings permutations is the substring of the second string. So that means we are given two strings and we have to check if the second string consists of some permutation of s1. So that means s2 should be greater than s1. So you know that it can be greater than or equal to. You can see the s2 is this. In this example you can see either. So s1 is ab and s2 is this eidba. So we have to return true or false if the first string is in the second string as some of its permutation. So AB, you can see AB is one of the permutations, so it can be also written as BA. So we need to check if AB or BA exist in the S2 as its substring. You can see substring of the second string. So otherwise if it is existing, you can see AB, here you can see BA exist. So BA is the substring of S2, which is also the permutation of string 1, that is BA. So that is why we will return 2. Otherwise in this example you can see AB. So S1 is AB, the S2 is, you can see EIDBOAA. So here we have to you have to note this word. So it is written substring. So here you can see BOA. B and A have occurred, but they are not continuous. They are actually forming the subsequence. They are not substring. So here our answer will be false, because there is no substring in the S2 which is permutation of S1. So that is why we will return false. So you can see the input strings only contain the lower characters. So that means we don't have to worry about the capital characters. So let's see the length of the both strings is in range 1 to 10,000, or you can say 10k. So the string length is actually medium size. So let's see how we can approach this question. I will explain you all the approaches starting from the naive and then to the optimal. So let's see. So first of all, you need to see this example that we are given. So okay, this example that we are given, how we are getting that output true. So I will explain you. So let's see. So you can see this string that we are given. So this is actually the S1, and we have to tell if this S1 exists in the second string as some permutation. So permutation is actually, you can see this is the string that we given. So its permutation can be actually AA, CB. Okay, it can be like this, or its permutation can be like BA, CA. So it can be like this also. So this is also a permutation, and you can see. So what we have to do is, now we will have some permutations. We will have some permutations, and we have to traverse the second string, and we have to check if some of the permutation, or if one permutation of the first string exists in this or not. So here you can see, if you traverse the string, so you can see BA and this. You can see this thing. So this string exists, this substring exists in this second string, which is also the permutation of the first string. You can see here we can form this permutation. You can see BAAC. So this string this first string that exists in the second string as some permutation. So this is 2. So we have to return 2. So this is what we have to do. So let's see how we can approach this using the naive approach to start the interview question. So let's see. So let me select the marker. So actually you can see in this example that we are given. So what we can do is, first of all, the naive approach for solving this will be simply as I told you. We have to check all the permutations of S1 if the permutation exists in the S2 as a substring or not. So what we can do is, first of all, we are given S1. Okay, we will check. We will have a string S1. So what we can do is, we can make all the permutations of string S1. So you can see one permutation will be this, other will be A, C, B, or then other will be B, C, A, or B, or you can say BAC. And similarly we can generate all the possible permutations of the string 1. So it will take, you can see, it will take exponential time, because you are generating all the permutations of a particular string of size n. So what we can do is, now we have generated all the permutations. Okay, all the permutation of this string. So we have stored it in some array or something, some data structure. What we will do is, now we will traverse over the second string, and we will take that this is of size 3. So what we will do, we will take a window of size 3, and we will check if some permutation in this array that we have stored is similar to this thing substring or not. We will then you can see I've written the pseudocode also. First of all, we will generate all the possible permutations of the string S1. So it will be like this, A, B, C, and all the permutations. Then we will check all the permutations one by one if some permutation exists in the S2 as a substring or not. So this approach will be actually the very naive approach, and it will be difficult to implement also, because we will have to write the different code for like first of all creating the permutations, then we will have to store them into the data structure, then traverse with the string and find for the true or false answer. So you can see the time complexity for this will be exponential time, you can see and factorial. Then space complexity to store this will be n square. So you can see I've written simple pseudocode. So this will be a good approach to start in an interview. So the interviewer will ask you to optimize this further, because this is a very basic approach. So there must be another way also to optimize this approach without finding the all the permutations. So let's see in the next method. So next method will be actually using sorting. So what we can do is, we are given this first string, okay, this is not sorted, so we are not given any sorted string, so we are given this string. What we can do is we can simply sort the s1. So this can be sorted, so it will be actually becoming a b c. So you can see we will sort it and it will become a b c. Now what we can do is we can take out the substring of size n. This n is 3 here, so we can take out the substring. We will traverse over this array and we will take the substring of size n. So n will be 3, so we'll take this substring, okay, we will take this substring and we will sort it. So its sorted version will be actually, you can see d e I. So this will be the sorted version, and we will similarly we will take first this string and sort it and check if this string is equal to the s1 or not. If it is equal, we will return true, otherwise we will go to the next string. So it will be next string will be idb. So you will sort it and you will check if it is similar to this or not, because you know that when you sort a string, so it will become similar to the other string. So here when you will reach here, you can see bca. So when you will reach here bca, you will sort it, so it will become actually abc again. Now if you compare this substring and this s1, so they are equal. So now you know that there is some permutation of s1 which exists in the s2 as a substring. So then you will return true. So this method, you can see I've written pseudocode. So it will be actually, first of all we will have to sort the s1 string that we are given, then we will have to traverse over the s2 string and take all the substrings starting from the 0th index to the n index of size n. So n is 3 here, n is the length of first string. So you will take that string and sort it. You will sort it and compare it with the s1, sorted s1. If it is equal, you can simply return true, otherwise you can you will traverse over the whole array. If the function does not return true, you will simply return the false after the end. You can see I've written, then compare the sorted s1 and the sorted substring from the s2. So this approach will take the time complexity of, you can see, n log n plus n. So you will feel like it is very complex, this time complexity. So actually it is simply the first string that we are given, so it is of length n, okay, it is of length n. So to sort a string, it will be the time complexity will be actually n log n. You know that we can use merge sort or quick sort, so the time complexity will be n log n. And when you traverse a string, you are also sorting the substrings. So here you can see this m minus n is actually, m is the length of this string and minus n is actually due to, because when you're taking a window of size, you can see n, so you will stop your loop till this point. You will not go till the end to n, because you have to like have the substring of size actually the n. So you will stop before m actually. So you will stop at m minus n. So I'm not able to write it here. You can see it, we will stop at m minus n. So into, because you will have all the substrings of size n, okay, and then you will sort it to compare it with the s1. So for that also time complexity will be n log n only, because you are taking the size n substring only, because you have to compare it with the first string s1. So that is why the time complexity for this will be the time complexity of to sort the first string and then to sort all the substring in this string and compare it with this. So total time complexity will be n log n plus m minus n into n log n. So this will be the sorted approach. So but this will be the good approach to start in an interview also after the naive approach. But this approach, this naive approach and this sorting approach will not get submitted into the Leetcode. They will result into TLE. So you will have to optimize it further and think a different solution. So let's see how we can solve this question by optimal solution. So let's see. So here if you see this string actually carefully, so I will tell you first of all what is an anagram. So let's see what is an anagram. If you are given a word T, okay, you are given a word T or you are given a word eat. So these both words are anagrams. And why, how you can say that? So actually anagram is the word whose all the characters, all the count of the characters is similar to the other word. So here you can see T occurs one time and E occurs, you can see T occurs one time, okay, T is occurring one time and E is also occurring one time and A is occurring one time. So this is the first word. And the second word, you can see here also E occurs one time, A occurs one time and T occurs one time, and you can compare these things. So you can see T occurs one time in both and E also and A also. So that means they are both anagrams of each other. So that is it, they contain the two words which contains a similar characters and similar number of times, but they are not in the same order. That is called the anagram. So now we will use this anagram thing to solve this question, actually the anagram approach to solve this question. So here, as I told you, in the previous approach, we were sorting the string S1. So now what we will do is, you can see we are given this string. Okay, we are given this string A, B, C. This is our S1. Okay, this is our S2. So here you can see if there exists a substring which is some permutation of S1. So it should consist of the same characters, same number of characters occurring in different order, but there should be same number of characters and same their count should be also same. So here you can see in the first string, A is occurring one time. Okay, A is occurring one time, B is occurring also one time, and C is occurring one time. So that means we have to find a substring of size n. So n is 3 here, so we have to find the substring of size n in the string 2 that we are given, which consists of this, okay, this these characters and this number of time. So here you can see, when we reach here, you can see B, C, A. So it is actually, you know, the answer for this is true. Actually, if you solve this here, you can see answer is true. So that is why you can see, so here we have to return true. So how we can check that? You can see B occurs one time. Okay, B occurs one time, so that means this is similar. Okay, C occurs one time, this is also same, and A occurs one time. So that means at this point, both the words or this substring or this this string are consisting of same number of characters occurring same number of time. So that means they are anagrams of each other. So that means there is some permutation of S1 which is in the S2 as a substring. So we can simply return 2. So let's see how we can code this, or how we can actually use, how we can like implement this. So I will explain you first of all the pseudocode actually, or run a dry run here. Let's see. So actually this is example that we are given. Okay, so what we will do is, first we will make a hash map, or we can use a hash map, or also we can use a count array. So first of all, I will explain you using the hash map, then we will implement the count array in the code. So a hash map will be easier to explain. So let's see what will be the hash map for this actually. So if you don't know what is a hash map, you can check it out from the internet also. It is simply a key value pair data structure. So here our key will be the character. So key will be the character. So we will traverse over the string. Okay, we will traverse over the S1 string, and we will create a hash map. So the hash map for this will be actually A. Say A has occurred one time, so its value will be 1. So this A is the key and value is 1. So the next character will be B. So B has occurred one time. So here also it's this will be 1. If and here you can see C has occurred also one time. So here its value also will be 1. If in this string one more A was given, then our count here the count of A is 1. So that means now A has occurred 2 times at this point. So we will update it. So we will simply increment it. It can become 2. So this is what we do in a hash map. So here we have created the hash map for the S1 string. So this hash map is actually for the S1 string. You know that this is for the S1 string. So now what we have to do is, we have to also create the hash map for this string, but we cannot do it like simply. So what we can do is, we can create the hash map for first 3 characters, because its size is equal to this. So we have to, its size is n. So we will create the hash map for this string also for the size n, first size n. So it will be actually, you can see eid. So we will create the hash map for this. So hash map for this will be actually, you can see E occurred one time, okay, I occurred one time, and D also occurred one time. So now our approach will be to compare this both hash maps, or you can say we will use a count array. So we will compare these both hash maps or the count arrays traversing over this array. So now you can check they both are equal or not. So they are not equal. So that means this EID is not similar or not a permutation of ABC. So now what we will do is, we will compare this string. It is not like you can skip this all. So you cannot compare BCA directly. So you will have to take this also, IDB. So you will take IDB. So now our hash map will change. So here you can see IDB. So in this hash map does not contain E value. So E will be eliminated. So E will be eliminated, and I is still there, D is still there, and B will be added. So B will be added. So B occurred one time. So again you will compare this hash map. So you can see you will compare this. So now they are not equal. So how we are doing this? Actually, let me tell you one more concept. How we are doing this? Instead of calculating a hash map for each substring, what we can do is, we can use a sliding window approach here. So actually the sliding window approach will be simply, you have created the hash map for the first window. So you have created the hash map for the first window. E has existed one time, and I existed one time, and D also one time. So what we can do is, instead of calculating the hash map every time, we know that we are only adding one character and eliminating one character. So what we will do? So for this thing that we are given EIDB, we have hash map for this string. Okay, we have hash map for this substring. So what we will do is, we will eliminate this character from the hash map. So we will simply eliminate. We will slide our window. So our window was at this point, and now we want our window to slide to the next character, eliminating the last character. So what we will do? We will simply eliminate even. So we will check if this character is in our map or our array, count array or not. If it is there, we will simply eliminate it. If it is not there, we don't have to do anything. So now what we will do? We will, when we are adding this character to our window, we have removed this character, so we have removed this from the hash map. So now we are adding this character, b is added, so b will come here. Okay, now b's frequency will be increasing, so it will become 1. So our hash map has updated, you can see. So this in this similar way we will use this sliding window approach to solve this question. So now, as you know, let's like complete the diagram. So here we were on this window IDB. So now we will compare this. They are not equal. Okay, they are not equal. So now our this window will increment. So it will become DBC. So our I will be eliminated and C will be added. So actually C has also occurred one time. So now you compare both the hash maps. So you can see all the values are not equal. You can see B has occurred one time. Here also B has occurred one time. C has occurred one time. Similar, but D has occurred one time. And here A has occurred one time. So that means it is not the permutation of that string. So now our next thing will be BCA. So now D has been eliminated. So D will be removed from this because it was in the last window. Now A is added to our current window. So it will be this A. So A will be added. You can see in this hash map will add A. So you can see this is added. Now if you compare both the hash maps, they are equal. You can see they consist of A, B, C values, and also their counts are equal. So now we will return 2. So now I will explain to you using the hash map. I hope you understood how you can solve this using the hash map. But now to implement this, it will be easier to implement it using an array or a vector. So let's see how we can implement it using a vector. So we will create a vector of length 26 because you know that there are 26 alphabets or characters. So we will create a vector of 26. So to map these characters to this indexing 0, 1, 2, because you cannot use A as an index. So to map it to index, you can simply do the character that you are on A minus the ASCII value of A. So actually the ASCII value of A is 97. So here you have to map A to the starting index, that is 0, and 26 will have the value as Z. So for that your 25 will have actually the value of Z. So let's see. So you know that ASCII value of A is 97. So if you subtract 97 from 97, the value will be 0. If you subtract 97 from 97, the value will be 0. So that means A will be matched to the this A will be mapped to the 0th index. When you have B, so B's ASCII value will be 98, but you will subtract from that also. From every character you will subtract a value of this ASCII value of A. So small a. So actually it will be 97 only. So when you subtract 98 from 97 or 97 from 98, so it will become 1. So B will be automatically mapped to the first index. And similarly for C also it will become 99 minus 97. So it will be mapped to this second index. So that is why we will use this this character actually vector instead of using this hash map. So the time complexity for this solution will be actually, you can see I've written here. So it will be actually n plus m minus n. So it will be actually a linear space complexity solution. Actually you know that, and the space complexity for this will be O of n because we are storing the characters, the count of the characters in the vector. So they will do a vector, so it will be actually 2n, or you can say n plus n. So here why this is n plus m minus n, because you know that first we are creating the hash map or the count array for the first string. So for first string the length is n, so you are traversing this one time, and then for the other one it is of length m, but you are not traversing it fully because you know that you will have to stop before the window at least windows has at least size of 3. So you have to stop before that point. So it will be at this point, you can see this O. So it will not traverse till whole m, it will end before m minus n, till m minus n, because we have to at least maintain the window of size n. So for that you will subtract from n minus m. So that is why the time complexity will be n plus m minus n. So let's see the code. So I will also provide the code in the description, the C++ code. So let's see. So first of all, as you know, we have to return true and false. You get true and false, result as true and false. So the type of the function will be bool. So let's see. So first we are given the two strings. So we are taking the size of the string, and at this point, as I told you, we have to also check the size of the first string should not be greater than the s2, the size of the second string. If that happens, then that means that s1 cannot exist in s2 because its size is greater than s2, so it cannot exist as a substring in s2. So that means we will simply return false. If at any point, if in any like test case the size of the first string is greater than the second string, we will simply return false. Then we will create or initialize two vectors. So these vectors will be actually the count array for the first string and the second string. So it will be, you can see, of size 26, and we will initialize them with value 0. At first we will initialize them with value 0. So now we will calculate the hash map or the count array for the first string and the second string till this point. In this string that we are given, you can see in this string that we are given, first we will initialize the hash map for this. Okay, so we are traversing from 0 to n. This is of size n, and for this also we will traverse from 0 to n and create a hash map in the same loop. So instead of wasting a loop, we can simply create the hash map for the second string also for the n size in this loop only. You can see here I will subtracted, so this will iterate from 0 to n the size of this first string, and then it will subtract the character minus the ASCII value of a, which is 97. So it will be mapped to the 0th index if it is a. So you can see we are simply incrementing the value if it is occurring or not. So then we have till this point we have our this count array. Then we will use our sliding window approach to check if the first string has the second string as a substring or not. So for the second loop, we will start from, you can see s will be 0 because we are starting from the first of all 0, and our end will start from the n. So n is our at this point, n is at this point, and s is at this point. So our loop will this loop variable will be starting from this point, and it will end till this point, and our s will be this at 0. So it will maintain a window size or sliding window of size at least n. So you can see here it is a simple code, you can understand it. So I've already explained the logic, and you can simply compare the vectors. You can see these are actually the vectors, not the variables. C1 is equal to C2. If the C1 and C2 are equal, you can simply turn true. At this point you can see here the variables were equal, this hash maps or the count were equal. So when you have this as equal, so you can simply turn true. Otherwise you will simply remove the last character which was occurring in the previous if you are on this, actually let me erase this. If you are on this window, okay, you are on this window, and this window size is of 4. So when you are iterating over the next window, you will simply remove the last value. So you can see last value will be actually the s is the starting. So 0 will be removed and the e will be added. So e will be our next variable, so e will be added. So that is why you are doing that. And now you can see we will also increment the s plus plus, because s is a variable, s is a count variable, so you have to initialize or increment it yourself. The e will be incremented automatically because it is running in a loop. So then at last also we will check if the c1 is equal to c2, then we will simply turn true, otherwise we will return false. That means there is no variation or the permutation of s1 which exists in s2 as a substring. So this will simply solve your question. So let's see, submit the solution. So I will also provide this code in the description, you can check it from there. And guys, do not forget to like and subscribe this video or subscribe the channel for more such videos. So you can see it got submitted and it took less time than 60% of solutions and less memory than 60% of solutions. So thank you for watching guys. I hope you like this video.